All right. Okay. I have some bad news. I was looking at the syllabus and I realized that I did not have the correct course policies on here. So if you've read through them, which maybe you did, these were not here and I just wanted to point them out. I haven't seen any issues so far in the first hour or so, but I do have a policy about electronic devices. You may use a laptop or tablet to take notes or look at if you have the course packet and you want to look at it on your electronic device, that's fine. But any other use of phones for like sitting there doing whatever, socializing, texting, updating your status on whatever it is that you use, I don't allow that in my class. So if you need to go and like update your status or something, just step out of the room and then come back. You know, just don't be during class on your phone, all right? It's a distraction to me, and I quite frankly, I find it disrespectful. So, all right? Yes?
If we don't have a calculator yet, can we use it?
Today you can, yes, but I want you to have a calculator by next week.
Okay.
Yeah, today's fine. You know what this is here for, right? It's just for just that, you know, sitting there the whole time, all right? All right, but that is updated on the website. All right, we're going to move on to a different topic now, and I thought I would start it out with a good problem, just to get you thinking here. $12 divided by 4 times 3. All right, we're gonna take a volunteer first, if there is a volunteer, and then we'll take a vote on how many people agree or disagree, or if we have multiple answers, we'll see. So anyone want to, yes? What do you think? What do you think the answer is? That's what I'm looking for. The answer is all I want.
I think the answer is
1, okay. Yes? 6? 1? We'll do a vote. But are there any other answers other than 6 and 1? No? 9? 9? Are you changing your 6 to 9?
Yeah.
Okay. All right. So let's do 1 is one answer, or 9 is the other one that we're getting here. So don't be shy. Let's take a vote. Vote for 1. Okay. Vote for 9. All right. That's not quite half and half. I think the ones have it. So the answer is 1, right? No, that's not the way we do math, right? It's not a majority. It's one way. Okay, so let's just make sure we understand how we are arriving at both of these answers. To get the 1, I think what's happening is 4 times 3 is happening first, and that gives you 12, and then you're doing 12 divided by 12, which is 1. Yes? That's how everyone got to the 1? And then for the 9, looks like they're doing the 12 divided by 4 first, which gives them 3, and then 3 times 3 is 9. So let's hear some arguments for each one. You want to argue for 9?
I'll
Okay.
argue for 9.
Yes.
So it's order of operations. So you go from left to right.
Okay, so what are the order of
So
operations?
it's multiplication or
You have this thing,
yeah.
PEMDAS. Okay, show of hands, how many of you have seen that, PEMDAS? Who has not seen PEMDAS? It's okay if you haven't. It's not like I'm going to be like, have you seen PEMDAS? No? Have you seen PEMDAS? No, you haven't? Okay, I'm just curious. No, I'm kidding. Okay, so there's an order in which we all have to agree to do things, or else we're going to get different answers. All right? And you wouldn't want to be building a bridge and one engineer is sitting there doing it one way and another one's doing it another way, right? We all have to have an agreement upon the order, because you can get different answers depending on the order. So this is the standard way that we teach the order. You always start and you do what's in parentheses first. That's what the P stands for. Then the E stands for exponents. You do exponents next. And then this is where things get tricky. Multiplication, division, addition, subtraction. The way that it's taught is incorrect most of the time. And by the votes for one, I can tell most of you learned it incorrectly or you don't remember it correctly. Multiplication division is not multiplication before division. It is multiplication or division, whichever appears first as you move from left to right. And addition and subtraction is the same exact thing. It's addition or subtraction, whichever appears first as you read it like a book from left to right. So when we do this problem, we have just multiplication and division in the problem, right? So we're going to do it in the order in which, as if we would read it like a book from left to right. So multiplication does not, I was going to say trump this, but I don't want to get political or anything in here. So multiplication does not come before division. It's from left to right. So you'll actually do the division before you do the multiplication. So we're going to do this first, which is 3, and then you do the times 3, so the correct answer is 9. So by the votes in the class, there were a lot of people that said 1, so you've learned something today. Good. We've accomplished something, right? This is the correct answer. Okay? I remember I was given this problem when I was in college, and I was very upset because I don't think that I was taught wrong. I just don't think that it was emphasized enough for me to remember. I just thought PEMDAS, that was it. Multiplication always came before division, and that was the way the world worked, but that's not the case. If you get on your calculator right now and you type in 12 divided by 4 times 3, it's going to say 9. Because it has built into it, the program, it will do the correct order of operations. Okay? All right. So that's what this next section is about, is order of operations and how we do things. And we're just going to start working through some problems. You do what's in parentheses first, then exponents. And every single time you do like one operation, you have to restart PEMDAS over. So you do everything in parentheses, and then once you do that, if you have more parentheses, you do that again, and then you just keep working. All right, so here's some to work on here. Why don't I see, let me see here. 1, 2, 3. Let's work on number 1 together. 5 minus 3 plus 72, parentheses, 10 minus 2, close parentheses. And I think I'll write it down over here. 5 minus 3 plus 72 times 10 minus 2. There we go. So there's what we have, right? So what am I supposed to do first? 10 minus 2. And 10 minus 2 is going to give me 8, right? And if I have an 8 sitting inside of a parentheses, I don't necessarily need the parentheses anymore because it's just one term. So I rewrite this as 5. And notice I'm going to put equals. And I'm going to rewrite the whole line. 5 minus 3 plus 72. And this turned into an 8. So if I put 8 here, what is the operation in between these now? It's implied multiplication. So there's not a dot written, but it is implied. It's understood that that is multiplication between these two numbers. So now what? I start over with PEMDAS again. I do anything in parentheses, which I don't have anything. Exponents, I don't have anything, right? Y'all know what exponents means, right? Like 2 cubed, that's an exponent. So I don't have any of those. So I move on to multiplication or division, whichever appears first. And in this case, all I have is multiplication. So 72 times 8?
576.
576. So we have 5 minus 3 plus 576. And now the two operations I have are subtraction and addition, and so I move from left to right. So 5 take away 3 would be 2 plus 576. And now add those up, you get 578. That's it. All right. Why don't you all take a few minutes to see if you can't figure out number 2 on your own? Is it big enough? Do I need to enlarge the screen, or can everyone see it? Sounds good? I'll put it back up there. Just give me a second. When you get an answer, raise your hand, and that way I just have an idea of when a lot of you are done. I would not try and do all this in your head. I mean, like write out each line. Because on a test, if you get this answer wrong and you don't show any work, you get nothing for it. But if you show work and I can see where you made a mistake, you'll get partial credit. So get into the habit of trying to write out each step. You have it? So we got one person, 2, 3, 4. I think what I'm going to do is start working it out, and then we can talk through it. Negative 104. All right, so what I tried to do here is kind of illustrate with the blue, like this is what I did to get me to the next line. So from here to here, all I did was 3 minus 6, which gave me negative 3. I left it in parentheses because there's multiplication here. If you accidentally forget your parentheses, you might think that that's 2 minus 3, which would be a problem. And I illustrate that on the next step. I actually put the dot there. But from here, I went in this parentheses, and I went inside and did 1 minus 4, which gave me negative 3, but I still need to square it. So that that negative 3 being squared became a positive 9. Does everyone agree with that? Negative 3 squared is positive 9. And I still have the squared here, but this 9 is inside the parentheses with the 1. So I add those together, that gives me 10. Everything else I'm just rewriting. Then I'm going to square the 10 because exponents would come next. Square 10, 10 times 10 is 100. Still have the minus out here. Then I have addition, multiplication, subtraction, so I do the multiplication. 2 times negative 3 is negative 6. So I have 2 minus 6 minus 100, and then the rest of it. What do y'all think of that one? Any questions on any of these steps? Sure?
On the parentheses, it's like outside and then it goes in?
What,
always?
in which part are you referring to?
Like the first one, like the beginning.
This?
Yeah.
Okay.
Oh no, the other one, the second. Like 1 plus parentheses, the one on top of that one.
Okay, here?
Yeah, like there, I don't get that.
Okay, so I have a parentheses, right? So basically what I do is I'm going to do what's in here first, right?
Yeah.
But inside this parentheses is another parentheses, so I actually need to do what's in there first.
Oh, okay.
So I'm going to do 1 minus 4, which gives me negative 3, right? But that is still squared, so I have squared, and I still have the 1 plus in front. That make sense?
Yeah.
So this became this piece right here, or actually that became this. Make sense? Yes?
So you just always have to take care of the inside parentheses first.
You always do, if you have a parentheses with a parentheses inside, you do the parentheses inside first. And then you can work your way out. Are there any other questions or clarifications that need to be made? You all right? Okay. I do have a question about something a little more, well, it's on topic, but kind of like that first problem that I gave you, where we did a vote. This one is one of those ones that people kind of get confused about. So what about this? What's negative 3 squared? So it's either 9 or maybe negative 9? So 9 and negative 9. Should we vote again or no? Yeah. No, we don't need to vote? 2 negatives become a positive? Okay, so maybe I should do this. Maybe I should show you that versus negative 3 squared. Is there a difference between those two? Does the parentheses matter? Yes. Absolutely, 100% the parentheses matter. The parentheses are not just there for fun, okay? They mean something. This says you're going to take, right, the squared means you're going to take whatever's here and multiply it times itself. The parentheses means that what you're squaring is the negative 3. So this is equal to taking negative 3 times negative 3. And that gives you positive 9, right? This does not mean negative 3 times negative 3. What this means, and this is what makes it tricky, this is the same as negative 1 times 3 squared. That's what this means. The negative out front is a negative 1. And the squared is only impacting the 3. So what you wind up doing is you square 3, which is 3 times 3, which is 9, but you still have a negative out front. So this answer to this one is negative 9. The answer to this one is 9. So in the previous problem, didn't we have negative 3 in parentheses? Remember we had 1 minus 4 squared? And when we did that, we did negative 3, and then it was squared. Did you see I put in parentheses? The parentheses actually needed to be there because I'm squaring the negative 3. If I would have left the parentheses off, then technically that would have been negative 9, not positive 9. So these are those little subtleties in math that can be confusing. Sorry, did I erase that too fast? All right. Okay, let's look at number 3. When you see this symbol, what is that symbol called? It's the square root. So just to make sure we're all aware of what a square root is. If you say square root of 81, what's the answer? 9. That's saying what number times itself would give you 81? Square root of 4, 2. What number times itself would give you 4? 2. What number times itself would give you 81? 9. Or you could say 9 squared gives you 81, 2 squared gives you 4. All right, that's just make sure we understand what the symbol means. But here, with that expression, when you see a square root, you have to treat the square root like a parenthesis. You have to do what's inside of the square root first. So we're going to do what's in here first. So that means I'm going to take 5 and square it. What's 5 squared? 25. And what's 3 squared? 9. Now 25 minus 9 is 16. And the square root of 16 is 4. So that would be the correct answer for number 3. Any questions on that? Did anyone want to try and do this a different way? No? Let me show you. Here's something that people do that's dangerous. Okay, this is incorrect, so I'll do it in red. This is not correct. But some people right here will do 5 minus 3, which is 2. So what they did here is they said, okay, see square root right here, 25 minus 9? They say, oh, I'm going to take the square root of 25, which is 5, and take the square root of 9, which is 3, and then subtract the 2, right, subtraction, and get an answer of 2. Do you all see that this is incorrect? You are not allowed to break up the square root onto these individually. You can't do that. So, no go here. All right, what about 4? What are those bars? What do these little bars mean? Absolute value. And all that really should mean to us is that it takes whatever's in there and it changes it to a positive number. No matter what's inside of it, it turns it into a positive. So when we do this right here, we have absolute value 4 minus 8. Also, you treat an absolute value like parentheses. Okay, so you do anything inside of here first. So 4 minus 8 is what? Negative 4, and then you have these absolute value bars around it. Minus 9. I'm going to go ahead and do what's in parentheses here. 2 minus 3 is negative 1. So the next line would be, what is the absolute value of negative 4? Just positive 4. So the bars go away, it just spits out the positive. What if that was already positive 4? It would still be positive 4. Okay, so whatever, absolute value just always returns to you the positive of whatever number is there. So if it's positive, it doesn't do anything to it. If it's negative, it switches it to positive. And what about this? This is kind of weird. We have minus, don't we? And we're supposed to do this multiplication. I'm supposed to multiply those two numbers. What's 9 times negative 1? Negative 9. And I'm subtracting, right? So it's minus minus 9. So it's minus negative 9. And when you see minus and minus next to one another, it switches to plus. So double negative becomes a positive. And then 4 plus 9 is 13. All right. I think I'm going to do maybe one or two more of these. I'm going to let you pick which one you want me to do. I'll do 2 more. There's 10 of them here. I'll let you all as a class choose which 2 you want to see, and then we're going to move on to the next section. We've done the first 4. So any of these look somewhat interesting? Maybe you'd want to see it done?
Maybe number 6.
Yeah, I was hoping you would say 6. 6 looks like kind of ugly. What else? Any of those?
10.
Yeah. What is that? what's this square? What is that? That's -1. That's what I was just talking about a second ago. It's not in parentheses, so that would be -1, not +1. Okay, so you want 6 and what? 10?
Yeah.
6 and 10? These are somewhat similar? Yeah? Okay. Let's see. Let's see number 6. It's 1 plus 2/5 plus 1/3 divided by parentheses 2 cubed. So what should we do? What should we do first?
The exponent?
The exponent, right? There's no parentheses, so I'm going to do the exponent first. So this becomes 1 plus 2/5 plus 1/3 over, what is this to the third? What does this mean? Yeah, 2 times 2 times 2. So that's 8. Okay, what should come next? What should I do next?
Add the fraction.
Add these two fractions. So this division bar means do division, right? That should be the next thing in order of operations. But when you have your numerator has two terms in it like this, you want to almost look at like this is in parentheses. This division bar, you have to do everything that's up here first, then everything that's down here, and then you can put them together. All right, so I need to add those two fractions together first. And we could add those, couldn't we? We did that a little while ago. And this would become something like, and I'm not going to show the work, but it would become, let's see, 6, 5, 11/15. Isn't that what we would get?
Yeah.
Now this is kind of complicated right here, all right? This is a little tricky. Yeah, it's a fraction, but it's already part of another fraction, so this looks weird. So let me show you something before we attack this. What is that equal to? 1, how'd you get 1? So you did 8 over 2 is 4, and then you did 4 divided by 4? That's one way? You could have done it, could you have done it another way? You could do 4 over 8 first, which would be 1/2, right? And then divide that by 2. What I'm getting at is this. There are two ways to do this problem. One way would be do 4 over 8 and then divide that by 2, right? That's one way. Or you could do 4 divided by the 8 over 2. Understand? There's two ways to do it. You get two different answers. So which way is right? Well, you can't tell because I intentionally drew this fraction incorrectly. This is bad notation. I actually need to make one of those division bars longer than the other one to make you know which one it is. So if I do this bar bigger than that bar, then that means we are doing this one. Do you all see that? Okay, so the length of the bar matters here. So you see how we had this bar above the 8? See that? Then we put these together and got 11/15. This bar is the bigger bar. So we are actually taking 11/15 and dividing it by 8. We are not taking 11 and dividing it by 5/8, if that makes sense. Do y'all see the difference or the similarity between this and this? Sure? Okay, so let me rewrite this. This is now 1 plus 11/15 divided by 8. Is that it? Is that another way I could have written that? Yeah? And then that's 1 plus 11/15 times what?
1 over 8.
Times 1 over 8. So what I'm doing is I'm looking at this 8 as being an 8 over 1, and then I'm flipping it and becoming 1 over 8. And how do you multiply fractions? Because that's our next step, right? We have multiplication, there's addition, so we do this first. Yeah, so I'm going to have to move this up here. It's going to be equals 1 plus 11 over 40, 120. It's kind of a messy problem, huh? Lots of room for mistakes here. And then how do you do this? You can do 1 over 1 plus 11 over 120. And then you can do that thing like this. So 120 times 1 is 120. Plus 1 times 11 is 11. Over 1 times 120, which is 120. So I think we're finally there. 131 over 120. Woo. What do y'all think about that? It's a little messy, huh? So we cube this first. Boom. Put those together, which we did on the side, got that. We had to make sure we understood that this meant this. Took that, rewrote it as 8 over 1, and then changed division to multiplication, flipped it straight across to here, common denominator, formula, put it together, answer. Like I said, I haven't done this class in 2 years, and I can remember students struggling with that problem on the test. Like a lot of students have trouble with that problem on the test. Well, a problem similar to that on the test. So I think it might be better for me to let you do number 10 on your own. Because 10 is similar to that one. Actually, 10's a little easier because it doesn't have that 1 plus out front. So you put those together and then, see if you can't work that out. I'll let you do that on your own? Is that all right? Okay, not right now, but should I move on? Yeah, you all right? Okay. Just don't make the mistake of sitting here going, yes, I know how to do all this, and then you don't do your homework and you don't get that practice that you need to be ready for the test, right? So even if you're like, yeah, sure, I got all that. You need that little bit of practice before a test or a quiz, or else you kind of, it's like anything else, right? Yeah, how many of you know how to ride a bike? Yeah, but when you get on, if you haven't been on it in 10 years, you still need a little bit of practice before you go race something, Got to kind of get used to it again. All right, oh, there were more. I think all these are within reason. All right. All right, let's look at linear equations. So this is the first time that we're actually solving something. Everything that we've done up to this point has been just arithmetic. It's been like adding, subtracting, multiplying, dividing. Now we want to go through and talk about solving what we call linear equations. Linear equations in one unknown. So let me start this out with a simpler version of a linear equation before we get into that. Okay, can anyone just look at that and tell me what the answer to that is? 2. Okay, so you just kind of threw some numbers in there, kind of messed around with it a little bit. Said, hey, if I plug 2 in for x, then this would be 2 times 2, which is 4, plus 1 would give you 5, right? But we need a more systematic approach to solving equations other than just looking and guessing at answers. Because if we get something like, I don't know, something like this, nobody's going to tell me what that answer is just by looking. And if you can, just look at that real quick and give me an answer, then you perhaps don't belong here. You belong in engineering class, math class. See, so what we need is, if we have equations, then do we have a way of solving them? Do we have a process, a systematic procedure for it, other than just like guess and check? So what is the systematic approach? Well, the approach depends on the equation. This is what we call linear equation in one unknown. If I change that problem to this, it is no longer a linear equation in one unknown because we have the x being squared. Now the answer is no longer 2. You said 2, right? It's no longer 2, right? So this squared right here makes it non-linear. This is called a quadratic equation. So this is linear, this one's not, right? So we have a linear equation. We have one unknown, meaning that we have one variable, right, in the entire problem. Here's an example of a linear equation with 2 unknowns. So here you have an x and a y, right? This does not fall into this category. So what I'm trying to get at is you need to know what the equation, what type it is before you can start attacking it. If you know you're looking at a linear equation with one unknown, then we have a certain procedure. Quadratic equations, we have a different procedure. Linear equation, 2 variables, we have a different procedure. So that's why the heading there on the section where it says solving linear equations in one unknown is very important. Because every problem I do in this section, I'm going to do the same way. So does anyone know what the procedure is? The actual technical procedure for solving a linear equation in one unknown. And I'll go back to this one. Isolate the x. That's the big thing. That's what we want to do. We want to isolate the variable. When we say unknown, when we said unknown, we meant variable. Sorry, I didn't point that out. But we want to isolate the variable. That's the goal. Now, an equation is like a balance, right? It's like a balance. And so you're allowed to add something to this side as long as you add something to this side, or you can take away on this side as long as you take away on this side. You can multiply this side by something as long as you multiply this side by something, right? You have this idea has already been implanted. All right. So I want to try and isolate the variable. Here's my variable. Right now I have what we call 2 terms. Terms are separated by addition and subtraction. So I have 2 terms over here. I want to first isolate the term that has x in it. If I can isolate it, isolate it. So to isolate that term, I would have to get rid of the 1 that's there. So how do I get rid of that? I would take away 1 on both sides, right? So I'm going to do what we call vertical subtraction. I'm going to just subtract 1 on both sides like that. And I'll still be left with 2x here. The 1's go away. 5 take away 1 is 4. I have my equal sign between. So I almost have the variable isolated. The problem is that I have a 2 attached to it. The 2 is being multiplied, right? So I need to undo that multiplication, and we undo multiplication with division. So we divide both sides by 2. So divide this side by 2, divide this side by 2. 2 over 2 becomes 1, and 1 times x would be x, and then 4 divided by 2 is 2. So we get to the same answer we had before by just looking, but we went through a more systematic approach. Does this all look familiar? Yes? Okay. So that was a very simple example. Let's get to the ones that are in the packet here. Okay, let's take a look at that first one. Is this a linear equation in one unknown? Yes, because you have x's, right? There's your unknown. You only have one unknown, and that's x. And x is never being squared or cubed or anything like that, so it's linear. Now, if I'm going to isolate x, that means I need to get x on one side of the equation. Right now it's on both sides, isn't it? So I need to choose like which side to get the x on. But I have a problem. I have a set of parentheses right here. So how can I resolve that parentheses that's around that x minus 2? Distribute. I would have to take this 5, there's multiplication here, and I have to distribute the 5 to each of those. And that would create a new line that looks like this, 5x minus 10 equals 4x minus 10. So all I've done there is just distributed the 5 through the parentheses. 5 times x is 5x, 5 times negative 2 is negative 10. Now, is there anything else I can do on the left side? Can I put these two together in any way? No. Can I put these two together in any way? No, because they're not what we call like terms, right? So now we choose. Do we want our x's on the left or the right? And it's totally up to you. You get to choose. There's no right way or wrong way. You just have to choose left or right. So any suggestions here? You want to do it on the left? Okay, so if I want to move my x's to the left side, I need to get rid of this 4x here. How do I do that? Subtract it. Subtract 4x. Whatever I do to the right side, I have to do to the left side. And let's go ahead and just do just that. If I did that, what would I have on the left side of the equation? X minus 10 would still be there. Equals, what's over here? Negative 10. So I do not have x by itself. I have x minus 10 by itself. So how do I get rid of? Add 10 to both sides. So if I add 10 here, I add 10 here, and add down, and what would I get? I'm going to have to continue this here. What's my new left side? These are gone, right? So just x equals, what's negative 10 plus 10? 0. And that is the solution. X is 0. Now, one good thing about solving equations is that you can always check your answer. So let's just check it real quick. What would happen if I were to replace this x here with 0 and that with 0? Would I have a statement that makes sense? So what's 0 take away 2? Negative 2? What's 5 times negative 2? Negative 10. So I would get a negative 10 here. If I replace that x with 0, I get 4 times 0, which is 0, and then I'd have minus 10. So it would be negative 10 on the right side also. So it works. What about this one? I have x's on both sides, so I need to get them all on one side. Is there anything I can do on the left side? I can combine these like terms. I have 2 x's, take away 5 x's. How many x's would I have then? Negative 3 x's. Here, how am I going to handle that? Distribute again, right? I'm going to distribute that 3 through. So what would I get when I distribute that through? 6x minus 12. So you're multiplying. 3 times 2x is 6x. 3 times negative 4 is negative 12. So I think now I've freed the x's up on the right side. I've got rid of that parentheses. I can't put these together. So now I just need to move my x's to one side. And again, we get a choice here. So which side? You want everything on the left side? That's fine with me. So if I'm going to move my x's to the left, get them all over there, what do I have to do to get rid of this? Subtract 6x. Subtract 6x. So what is negative 3x? Take away 6x's. Negative 9x. Equals, what's still over here? Negative 12. What is that? You don't hear that? Now what? Divide both sides by negative 9. So I'm going to try and undo this multiplication right here. So I'm going to divide by negative 9 here, divide by negative 9 here. On the left side, the negative over negative gives me positive. That's why I divided by negative 9. And that gives me x. On the right side, I have a negative over negative still, which is positive, right? And it's 12 over 9. But that reduces, right? 4/3. X is 4/3. So 3 goes into both of these. Yeah, so that would have been hard to look at this equation in the very beginning and be like, oh yeah, sure, x is 4/3, right? It's not something that we can see easily. That's why we have a procedure for it. All right, let's do, what is going on? We might need to use that window today already. Oh, I went too high. How about you try to see if you can't work out number 3? Give you a few minutes. I mean, we're on the 3rd floor, right? There's nothing above us. I'll go check it out. Number 3, right? Everyone's working that one?
Again, I was
I found the source. The classroom next to us, they've got a bunch of beach balls and they're throwing them around to each other right over there. Meanwhile, we're in here doing this. Right? Sounds like that should be the class you should have signed up for. It's a new faculty member. I think she's trying to have a bunch of activities, be fun. How'd it go? Y'all still working? I think what I'll do is, well, maybe work it and let y'all look up and see if y'all get the same thing here. Are y'all ready to talk? Okay, so in the very beginning, there's a set of parentheses around this 4 minus x, which is a little confusing. There's a plus sign in front of it, which really means that there's like a +1 here. Right? That's the whole reason this problem is presented to you, just to make sure you understand what to do with this. When you see a plus in front of a set of parentheses, you can just drop the parentheses. Nothing happens. Right? It's almost like you pass a 1 through and nothing changes. And then over here, pass the 2 through. So is everyone okay up to the second line there? Okay, and then the next line, what did I do to get the 9x plus 4 equals 13x plus 10? Combine like terms. So took 10x, took away 1x, and that gave us 9x, and we still had the plus 4. 7x plus 6x gave us 13x, and then still had the plus 10. Then the next line is where I chose that I was going to move everything to the left. And again, you could have moved everything to the right, but I said I'm going to put all my x's on the left. So I subtracted 13x here, subtracted 13x here. 9x's take away 13x's gave me negative 4x's. And then the 4 comes down because I didn't do anything to it. And then here the 13x's cancel and I just get the 10. And then the next line, still trying to isolate the x term, so I subtract 4 on both sides. And that brings me to this. Then divide through by negative 4. The negative 4's cancel, I get x. Here I just have 6 over negative 4, and that fraction reduces out to be negative 3/2. And that brings me to kind of a little question here. I put negative 3/2 like this. You could also have put 3 over negative 2. But you could also have put negative 3 over 2. All of these fractions are the same thing. When you have a negative on a fraction, you can put the negative out front, you can put the negative just on the bottom, or you can put the negative just on the top. You have the freedom of choosing where that negative goes. What you cannot do is put a negative both on the top and bottom, because then it's positive. Right? Negative divided by negative is positive. So all of these are equivalent and correct. We good? Sure? Okay. Let's see what else we've got here. Time we got 1:30. We have 10 minutes. Let's look at number 8. It bothers me that they're having so much more fun next door. Maybe we can make this class fun. Maybe what we can do is I can bring in a dodgeball. And then like I'll ask you a question. If you get it wrong, I'll throw it at you. And then, right? And then they're doing something like that over there. All right, look at number 8. This is a linear equation. This is a linear equation in one variable. So we have fractions, though. That always seems to cause a problem. So I'm going to write the problem down here again just to be sure we understand what it's, the way it's written. 5/7 x and then equals x minus 1. Now there are multiple ways to do this problem, but I'm going to show you what I think is the cleanest way to do it. And that is to first get rid of the fractions. We call this clearing fractions. And so what I do is I look at these fractions that I have. I have 2/5 and I have 5/7, and I try and find a common denominator, a number that is a multiple of both 5 and 7. So what is a number that's both a multiple of 5 and 7? 35. That's the least common multiple. So what I'm going to do is I'm going to multiply the entire left side of the equation by 35. And I'm going to multiply the other side of the equation by 35. Now, am I allowed to do that? Yeah, with equations, you can multiply both sides by any number you want. And let's just see what effect this has. I know it looks really bad right now, written like this. But this 35 is going to get multiplied through here and here. And then this 35 is actually going to pass through to here and to here. So let's do the right side first, because I think the right side's easier. What's 35 times x first? 35x. And then what's 35 times negative 1? Negative 35. Okay, so the right side, we good? It's the left side that's a little confusing. The left side, I have to do 35 times 2/5 x. I need to do 35, I'm going to do this on the side, over 1 times 2 times 5x. That's what I'm doing. And now this piece right here, we can do the way we've been doing multiplication of fractions. But notice that 5 goes into 35, doesn't it? Or 5 goes into 5 once, and 5 goes in 35 7 times. So this is really 7 over 1 times 2 over 1 times x, which is just 14, isn't it? 14x. So we have 14x here. And then what would I get if I did 35 times 5 7? So I'm going to do that here. If I do 35 over 1 times 5 over 7 times x, the same thing should happen. I should get 7 goes into 35, right? 5 times. So this is going to be a 1 and this is going to be 5. And so what would this give me? 25? X. Yes? Okay, good. I'm glad you asked about that. So notice that when I did this, I did the 35 times the 5 sevenths x, and I didn't even talk about the negative. That's because I'm just going to use it as like a subtraction. It's going to be minus, right? Minus. And then this number here, or this whatever we got here, so 25x. Is that all right? So do you see what I've done is I've taken this problem that had a bunch of fractions in it. I multiplied both sides by 35. And what I now have is a new equation that should have the same answer as this equation, but it has no more fractions. So it's easier to work with. So what can I do with that? Combine like terms on the left. What's 14x take away 25x? Negative 11x equals 35x minus 35. Now what? Yeah, move your variable over. So you want to get the x's on the left? Yeah. Okay, so we subtract 35x, subtract 35x. These will go away. And over here we subtract negative 46x equals negative 35. And I think we have another step to do here. Divide both sides by negative 46. Negative 46, negative 46. On the left side, we should get x. On the right side, we have a negative divided by a negative, right? Which is positive. So 35 over 46. Unless there's a number that goes into both of those. I don't believe there is. Okay, so for homework tonight, I'm going to go ahead and cut you all loose. For homework, just to be clear, it's in the packet, it's page 7 and 8. And then page 11 and 12. And I would say for page 11 and 12, I mean, do your best. We really didn't get to go through every type of problem with solving linear equations, so I would anticipate you might have some questions over solving the equations, especially on page 12. But we'll start class next time by, saying, hey, what kind of trouble did you run into on page 12 for the homework? All right? We'll see you on Wednesday.